Hey guys, today we're starting our unit on acids and bases. All right, so make sure you have a copy of the slides ready or the notes ready and we'll get going. All right, so you have acids and you have bases. To know if something's an acid, it generally has a sour taste to it. Think of lemons, okay? Lemons have a sour taste. Uh, Green grapes can be sour, tomatoes can be sour. All right, the more sour it is, the stronger the acid. All right. Acids, if you remember nomenclature, always start with H or started with hydrogen, like hydrochloric acid was HCl. Chloric acid was HClO2. Okay. So it always has that hydrogen in front. It's found in a lot of the things that we eat and drink. If you have something called litmus paper, which is like a little algae on a paper, if you have a blue piece of it and you stick it in something acidic, it will turn the paper to red. All right. Um, the pH of acids is generally a number between 0 and 6.9. We're going to talk about pH more in a couple of slides, right? And they tend to be corrosive, meaning that it eats away at whatever it's at. That's what this danger acid symbol is showing, that it's eating away at the hand, eating away at the counter. All right. When you put an acid into water, it forms hydrogen ions or hydronium ions in the solution. Okay, the more hydrogen or the more hydroniums present, the stronger that the acid is. Again, it's the free floating hydrogen ions, the free floating hydronium ions. That's what makes an acid be able to affect you more. Okay, if you don't know that H plus means hydrogen or H3O plus means hydronium, then I would write that underneath the symbols just to make sure that you know what we're talking about as we go through this unit. All right, so again, next to acids, if you want to write acids are sour, um, okay, and red's the color that tends to go with them. All right, then we have bases. Okay, bases are more what we look at with cleaning products. Okay, like oven cleaner is one of the strongest bases that there are. If you ever clean out your oven or see your family clean out their oven, okay, you spray the stuff in there, and then you leave the room, you shut the oven, and it just eats away what's ever been cooked onto the oven. All right. Um, have you ever said a bad word and your parents were like, "I'm gonna wash your mouth out with soap"? All right. It's a very bitter flavor. Um, I never said any bad words, but my sister did. So she would get her mouth washed out with soap, and it was very not good tasting. Okay, very bitter taste to it. If you're looking at a compound, okay, or a formula for something, then it's going to be to know if something's a base, it's going to end in hydroxide. So, like sodium hydroxide, which is NaOH, calcium hydroxide, CaOH2. All right. Those are examples of bases. Again, having that hydroxide ion creates a base. This time, if you have the red litmus paper or the red algae, it will change to the color blue. So a lot of time to remember bases, I think of bitter blue bases. Okay, the three B's, bitter blue bases. Right. The pH scale for bases is 7.1 to 14, with this one being the higher the number, the stronger the base. Again, we'll talk about pH scale more in a few minutes. Um, so we already talked about them being cleaning products, so lots of soaps and things like that. So think of the slipperiness of soaps as being another trait of the bases, but they're also corrosive. If you have oven cleaner and you get it on your hands, it will burn your hands. It will just kind of eat away at your skin. All right. Now the stuff that we use like Dawn soap and hand soap, those are really weak bases. So that's why they don't eat away at you. They actually help you. All right. Um, and if you don't know that OH is hydroxide, then I would write that on your notes as well. All right. So next we have, what does pH mean? Okay, so I talked about acids being from 0 to 6.9, bases being 7.1 to 14. All right. The P in pH stands for power. The H in pH stands for the hydrogen. So it's asking what is the power of hydrogen in the substance. It's referring to the negative logarithmic base 10 scale of hydrogen per 1 liter of solution. That sounds like a lot of math, okay? But it's not as bad as you think it is. All right. You'll be watching an Edpuzzle that explains this a little bit better at the end of class. But just so you know, for the rest of the slideshow, if you have a pH of 1, okay, a pH of 1 is a very strong acid. What that is saying is 1 out of every 10 molecule in 1 liter of water is going to be a hydrogen ion. All right, so that's a lot of hydrogen ion in 1 liter of water. But if you have something with a pH of, I don't know, we'll still do an acid, so something with a pH of 6, okay? So if something has a pH of 6, that means that 1 out of every, hold on, now I'm having to write this number down. Yeah, so add 6 zeros to the end of 1, because that's what the 6 is saying. It has 6 zeros at the end of the number. So if you have something with a pH of 6, that means 1 out of every million of the molecules is a hydrogen ion or a hydronium ion. Okay, so pH of 1 was 1 out of every 10. pH of 6 is 1 out of every million. That's what it's talking about by the logarithmic scale. And again, the video at the end of class is going to go into that in more detail. All right. But that's what pH is talking about, is how often will you find hydrogen? And the number is telling you how many zeros are at the end. Okay. So that's what this is saying. Is lemon juice more acidic than bleach? Okay. Yes. Every number you go up the pH scale, the strength of the hydroxide concentration increases by 10%. Because hydroxide and hydrogen are generally thought of as being opposite. Okay, so if lemon scale is a pH of 2, that's saying that in lemon juice, hydrogen is found 1 out of every 100 molecules. Bleach has a pH scale of 13, so that's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 13 minus 2, okay, is 11, and there's 11 zeros here, so that's 100 billion difference, okay, and how often you find hydrogen. So that's why lemon juice is much more acidic than a strong base bleach, okay? Again, because of how often you find the hydrogen. Water is amphoteric. So that means that water can act as both an acid and a base in an aqueous solution. Because guess what? Aqueous solutions are water, right? Water contains an equal number of hydrogen and hydroxide ions because water is H2O, also written as HOH. So 1 hydrogen with 1 hydroxide. Okay, it's equal. There's no more hydrogen than there is hydroxide because it's 1-for-1 ratio. That's why water has a pH of 7. Okay, that'd be 1 out of every 10 million water molecules might switch to hydronium. But you can add more hydrogen to it. You can add more hydroxide to it. It's right there in the middle. So that's why water is neutral. Okay. So this can kind of help you determine if something is an acid or a base. Okay. Something is neutral like water if it has equal hydrogen and hydroxide ions. It's acidic if it has more hydrogen ions and than the hydroxide ions. It's basic if it has less hydrogen ions than hydroxide ions. Okay. So again, I know I'm repeating myself a lot, but hopefully it's helping. The reiterating is helping you to remember. More hydrogen equals more acidic. Okay. More hydroxide is more basic. All right. And when it comes to the pH scale, the more hydrogen you have, the lower the number is going to be. Okay. The less hydrogen you have and the more hydroxide, the higher the pH will be. All right. Again, because the pH is telling you basically how many zeros are at the end. All right. So the fewer zeros, the more acidic. The more zeros, the more acidic. Nope, sorry, the more basic. I said that wrong. All right, so again, with the pH scale, it shows the strength of an acid or base on a scale of 0 to 14. Numbers below 7 are acids. The lower the number, the more acidic. Numbers above 7 are bases. The higher the number, the more acidic. Okay, so if we have a pH scale here, all right, remember acids tend to be red, bases tend to be blue. Alkaline that you see right here is another word for base. If you want to write that down somewhere, I encourage it because you could be seeing alkaline more. But again, alkaline is just another word for base. All right, so you have the power of hydrogen. There's also a power of hydroxide scale, which is basically the same thing as pH, but reversed because now you're talking about how much hydroxide is present. But whenever you're adding pH and pOH together, your number should always be 14 because the scales are 0 to 14. All right, so if something has a pH of 2, then what's 14 minus 2? 10. Yeah, so you're going to have a pOH of 10. Okay. If you have a pH of 4, then what's the pOH going to be? 14 minus 4 is 10. Okay, so you would have a pOH of 10. This last one, we give you the pOH of 7. Okay, so now we're going to do 14 minus 7, and that tells us that the pH is also 7. Okay, so again, it's pH plus pOH is always equal to 14. All right, let's see. Following along with my notes, making sure I am getting everything you guys need. All right, next we're going to talk about strength and concentration of acids and bases. These are terms that are easily mixed up. I have them highlighted on my notes to really stand out. I suggest that you highlight, circle, star, something to make these definitions stand out too. Okay? The strength of an acid or base is talking about how completely it ionizes. Ionizes means how completely it breaks apart. So like hydrochloric acid breaks apart completely into hydrogen ions and chlorine ions. They're no longer together. But you have other stuff like acetic acid, which sometimes stays together as the HC2O3 H2. Okay, sometimes it stays together, sometimes it separates into the hydrogen and the acetate. Okay, so strength is talking about, does it completely break apart like hydrochloric acid, or does it sometimes break apart like acetic acid? All right, so strong completely, weak only a little bit. And then the other definition on here is concentration. Concentration is how much solute is dissolved. All right, so we just got done with our solution unit. All right, this is the M1V1 equals M2V2. This is what it's talking about. All right, if something's concentrated, that means you have a lot of acid or base in just a little bit of water. All right, if something's dilute, that means you have a little bit of acid or base in a lot of water. Okay, so again, strength and concentration are often mixed up. Strength is talking about how much the ions stick together. Concentration is talking about how much water is involved. All right, sorry. I'm recording this during 6th period on Friday, and there's a loud thunder right now, so it's about to rain. Okay, so let's look at some examples of how you could see this. All right, so we have a 12 molar hydrochloric acid in this first example. All right, hydrochloric acid is a strong acid. Okay, 12 molars means it has a high concentration because remember, molar is defined as moles per 1 liter of solution. So this is saying we have 12 moles per 1 liter. That's a high number. So this is a concentrated solution. If you add 6 liters of water to this solution, it's still going to be a strong acid, because if it's a strong acid in the beginning, it's going to stay a strong acid in the end. That does not change. all right? But because we're adding water to this acid, instead of it being concentrated, we have now made it dilute, okay? Um, let's see. So let's go ahead and look at the second one, and then I'm going to tell you some stuff that you should write down, all right? So vinegar is acetic acid, which we were talking about. Acetic acid is weak. Sometimes it ionizes, sometimes it stays together, right? And in this case, it's in a low concentration, so it's dilute, all right? But if we have 12 molar acetic acid, it's still weak, but now that it's 12 moles per 1 liter, it's now a concentrated solution because now there's um, less water involved. All right, I think I meant to say that it was like a 6 molar solution in the beginning. I'm sorry about that. All right. The main thing that I want you to get from this slide and that you should write down next to it somewhere, okay, is that the strength never changes. Okay, strength never changes. I'm writing this down on my notes too, okay? If it starts strong, it stays strong, okay? Concentration does change. Concentration does change if you add water or if you evaporate water. Okay, so if something starts strong, it stays strong. If it starts weak, it stays weak. Okay, but if it starts concentrated and you add water, now it's dilute. Okay, if it starts diluted and you evaporate water, now it's concentrated. Okay, so those are the key things to get from this. Strength doesn't change, concentration does if you add or take away water. All right. Just to kind of reiterate the strong or weak, again, strong completely ionizes. Yeah, they're the ones that produce the maximum number of ions. Those are the ones that you're going to see as like the 1 on the pH scale or the 14 on the pH scale. Strong acids are a good indicator of how many ions are present, and the reaction only moves in one direction. So this is represented with an arrow in one direction. All right, so I know it's going to be kind of hard to see, but you'll see in my notes where I have the hydrochloric acid, all right, draw one arrow, okay, pointing towards the ions, all right, because once it goes to the ions, it doesn't go back to being the acid, it stays that way. But with weak acids or bases, these only partially ionize. Okay, so they're producing fewer ions. So these are going to be the things with the pH that's closer to 7. These reactions can move in both directions. All right, and so that's represented by either 2 arrows, one pointing in each direction, or just one line with 2 arrowheads on it. Okay, but that's saying that it goes back and forth from being ions to being a compound or a molecule, being ions to being a molecule. Again, because they're not very strong, so it can't decide what it wants to do. All right. Sorry, I'm distracted by the rain again. I like rain. All right. So another way to recognize the difference between strong or weak acids, all right? Again, it's all about the arrows. If it just has one arrow, assume that it's strong. If it has 2 arrows, assume that it's weak. Okay? And here's the visualization. The strong acid, it starts off as one compound, okay, or one molecule, but when it gets to the water, it's kind of hard to see, but nothing's together. These are all individual balls now. All right? Versus the weak acid that starts off as molecules, but now in the water, you see some of them still as molecules and some of them as individual ions. Okay, not balls, but ions. All right, so that's what we're talking about here. Okay, so hopefully today you're starting to understand the pH scale a little bit better. Again, you're going to be watching one more video over that. Let's see how to recognize if something's an acid or a base. Acids start with hydrogen, bases end in hydroxide. And then how to tell the strength or concentration of an acid or base. All right. So the next thing you're going to do is you're going to take a picture of your notes, turn it in so we can make sure that you did what you were supposed to. And then you're going to watch the Ed puzzle over the PH, answer all the questions, watch it all the way through, and submit it because that's going to be your grade for today. All right. Thank you for listening, and I'll see you guys later.